In science and mathematics, people often need to deal with extremely large or extremely small quantity. So for example, in science, the mass of an electron is this kilogram. So it's 0.30911 kilogram. So writing such number is very cumbersome. So therefore, scientists and mathematicians, they came up with a way to write a very long number in a more compact form, which is scientific notation. So the scientific notation of this very long number is 9.11 times 10 to the negative 81. All right, so let's say you want to write a number. So let's say I want to write 10,000, right? So this is 10,000, or you can write 1 times 10 to the fourth power, which is 1 followed by 40. So if you write 100,000, so this will be 1 times 10 followed by 50. You might say, okay, I don't see there is a big difference. All right, let's do one more. So let's say 1 million. So the reason we use a comma here is this. The reason here is why we have to use a comma. So when we read a long number, right? So you don't want to count the digits one by one. So we put a comma on every 3 digits that helps us to read, and that helps us to read the number. So this one followed by 60. So if you use a comma to separate every 3 digits, I can easily tell that that is 1 million. So which is 1 times 10 to the 6th power. You might say, hey, I don't see any difference between the 1 million and 1 times 10 raised to the 6th power. All right, so how about this? What if you have 1 followed by 1,000 zeros? Are you going to waste your time to write 1,000 zeros out? No, you don't need to do that. So you can write 1, and then how many zeros do you want? You want 1,000 zero, right? Then you raise that to 1,000 power. So that's why we use scientific notation. We want to, instead of writing a very long number, we can put that number in a more compact form. Let's take a look at scientific notation. So we have the first screenshot. This is the general form of scientific notation: a times 10 to the nth power. The value a is the Mantissa, and the number between, and a is a number between 1 and 10, including 1 but not including 10. So a is between 1 and 10. A cannot be equal to 10, but a can be equal to 1. So and the value n is exponent, and an integer is an integer, either positive or negative, and 10 is the base. So the base is always 10. All right, so the base is always 10. So the next screenshot, I did 4 computations. So the first one I did is I take 3 divided by a very large value. So a 3 divided by a very large value, the quotient must be extremely small. So you see 3.540274159, and then you see there is a e minus 6. So e minus 6. This you can call this a e notation. So in statistics, you will see this type of number in some of the chapters. When you see this type of number, you have to be able to tell that this is equals to 3.54. Usually we keep 2 decimal places. 1 is okay, but I get used to 2, and then times 10 to the negative 6. And when you see such type of number in a statistics class, you have to know that this number is a number that is very, very close to 0. So that is equals to 0.50, and then 354. The minus 6 means at 3.54, you move the decimal point 6 steps to the left. 1, 2, 3, 4, 5, 6. So this is very, very close to 0. So the next one is 13 divided by a very large value. You have 2.64 times 10 to the negative 9. You have to be able to write this, and you have to be able to tell that this number is very close to 0. 1 divided by a huge quantity is 1 times 10 to the negative 12. Can the first number be negative? The answer is yes. If you take a negative 5 divided by a very large value, there is no way to write a positive in there. So you write negative 3.86 times 10 to the negative 7. You have to be prepared to read this type of thing in your statistics class. Now, so it looks like scientific notation is so it looks like if you have a very large number, you need to be able to convert to a scientific notation, right? But how do we convert that? There are a few cases. I'm going to go over each of those in this video, starting with the first one. So the first one that you will have to learn is you want to convert scientific notation to decimal, right? So case one is you have to deal with positive exponent. So positive exponent. So positive exponent, so let's say you have a scientific notation 9.3 times 10 to the 7th power. You need to know what that is. So this is 9.3 times 10 to the 7th power means 1 followed by 7 zeros. So 1, 2, 3, 4, 5, 6, 7. So that means you have to move the decimal point 7 steps to the right. How do we do that? So here is how. If you have no experience in doing this, so you are moving the decimal point to the right, right? So this is how I do this when I was learning decimal notation. I write 9, 3, and then followed by a bunch of zeros. Just prepare a few more zeros. You start right here, right? And then start the counting. 1, 2, 3, 4, 5, 6, 7. So you start right there. So that means this is a 93 followed by how many zeros? Followed by 6 zeros. Right? 1, 2, 3, 4, 5, 6, 7. So that is 9.3 followed by 6 zeros. 1, 2, 3, 4, 5, 6. You can use a comma to separate every 3 digit. So let's do one more. How about 2.46 times 10 to the 9th power? So that means it's 2.46 times 10 times 1 followed by 9 zero. So that means you have to move the decimal point 9 steps to the right. So this is how I do it. 2, 4, 6, and then you draw a bunch of zero. You can draw extra zero because this is only a scratch work. You start at this point and then you move 9 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. So that is equals to 246 followed by how many? Followed by 7 zero. 1, 2, 3, 4, 5, 6, 7, and then you can use a comma to separate every 3 digits. All right, so that is how you do it. So this is a positive exponent. Of course, we have a negative exponent. So let's do a negative exponent. So case 2, we have negative exponent. So negative exponent. So this time we are still using a 9.3. This time I'm going to change the positive 7 to a negative 7. So what it does is you have a negative exponent, right? So you have a 9.3 times 1 divided by 10 to the 7th power. So what is 10 to the 7th power? That means you have 1 followed by 7 zero. 1, 2, 3, 4, 5, 6, 7. 1 followed by 7 zero. So that means you are taking a 9.3 divided by a very large value. So what is that going to be? So that means you are making 9.3 smaller, right? You take a 9.3 divided by a value that is so big, so you are making 9.3 smaller. When you do that, that means you have to move the decimal point 7 steps to the left. Here is how I do it. So I write a 9, 3, right? And then I prepare many zeros on the left. And then I start the move, starting right here, right? 1, 2, 3, 4, 5, 6, 7. So we start right there. So that is equals to 0 point. How many zeros? Right here. How many zeros? 6 0. 1, 2, 3, 4, 5, 6, 9, 3. That's how you do it. So let's do one for the 2.46. This is a positive 9. Let's do a negative 9. So we have a 2.46 times 10 to the negative 9. So this is a 2.46 times 1 divided by 10 to the 9th power, right? So which is 2.46 divided by 1 followed by 9 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means you are making 2.46 smaller. Making 2.46 smaller means that you have to move the decimal point 9 steps left. And then here is the scratch work. So we have a 2, 4, 6, and then we draw a bunch of zeros. And then we start the move starting at this point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where we stop. And then how many zeros do we have? We have 6, 8 0. So that is equals to 0.8 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, and then 2, 4, 6. So this is how we convert from scientific notation, convert a scientific notation to decimal. How about from decimal to scientific notation? Let's do that too. So now we are trying to do convert decimal to scientific notation. Alright, so the case 1 is very large value and positive exponent. So we have case 1, very large value and positive exponent. So let's say we have a 314 followed by, let's make it big, followed by 6 0. How's that? 1, 2, 3, 4, 5, 6. How about this? 9 zeros. What is that equal to? This is a very large value. And then how do we convert this to a scientific notation? So first thing first, we have to write the Mantissa. The Mantissa must be between 1 and 10. 1 is okay. Is this correct? Is this between 1 and 10? No, that is not right, right? So that is not right. Okay, let's erase this. Can I have 314? No, 314 is not between 1 and 10. So the only option is 3.14. All right, and then times 10 to the some power, right? What number goes there? So this is how we do it. So let's switch color first. So you want 3.14, right? How many steps do you have to make? So this is a 3.14. This is a 314 followed by so many zero. So that means you are making this bigger, right? So you are trying to make 3.14 bigger. So that means you have to use a positive exponent. All right, starting at 3.14. So let's do the move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we make 11 steps to the right. So this is positive 11. So that means starting at 3.14 and then move the decimal point. The decimal point 11 steps to the right. So that's why we need to use a positive exponent, because once you multiply 3.14 by that large value, you are making 3.14 bigger. All right, so let's do the next one. I'm going to give you another number. How about this? 2036, this time followed by 60. And then let's use a comma to separate the digits. So this, we have to start with 20.36, right? Is this correct? No, it is not right, because 20.36 is not between 1 and 10. How about 203.6? Can we do that? Nope, this is a wrong Mantissa, because that is not between 1 and 10. Okay, so we have to fix that too. So what is correct? The correct things to do is 2.03. 2.036. So now this number is between 1 and 10. And then you multiply base 10 raised to some exponent. So what you are trying to do is you are trying to make 2.036 bigger, right? So that means you need a positive exponent. Positive exponent means you're starting at 2.036 and then you move the decimal point, this decimal point, how many steps to the right? We don't know, right? Let's find out right now. Starting at 2.36 right here. Let's do the move. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 steps. So this is 9 steps. That means this is 10 raised to the 9th power. All right. So that is case 1, very large value, right? How do you convert a very large value to scientific notation? And then case 2 is very small value and using negative exponent. So let's write the word case 2. So we have case 2, very small value and negative exponent. So let me give you a very small value. How about the 0.50? So 0.1234550 What is the Mantissa? The Mantissa is 752. Nope. 75.2. Nope. That is not between 1 and 10. The only option is 7.52. Not 75.2. 7.52 is between 1 and 10. And then you multiply 10 raised to some power. Compare the 7.52 and a very small value. Which one is bigger? The 7.52, right? So now your job is you want to make 7.52 smaller. To make a number smaller, you have to use negative exponent. All right, so that means you have to move the decimal point a few steps to the left. So that means you have to move the decimal point some steps left. How many? Here is how many. Starting at 7.52, let's count. 1, 2, 3, 4, 5, 6. So that is 6 steps. So that is 6 steps to the left, and this will be a negative 6. Let's use an even longer number, and that number is very close to 0. So let's do that. So I am going to give you another number. So that is 0. Let's see. How about this? 12, 0. 40, 75. How about this? What's the Mantissa? The Mantissa is 4.075, right? That is between 1 and 10. There is no other option. And then you have to multiply 10 raised to some power. So that means you are trying to make, use another color, make 4.075 smaller. Therefore, you have to use a negative exponent. So how many steps you have to move? You have to move the decimal point some steps left. How many? Starting at this point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You have to make 13 steps left. So this will be a negative 13. This one, the 4.075, I keep 3 decimal places. So for the Mantissa, you can either do 4.08 or you can do 4.1 times 10 to the negative 13. So either you keep 2 decimal places or 1 decimal place. I get used to two decimal places because I have been using this for a long time. So going back to this problem, you can do this, or you can do 2.04 times 10 to the 9th power. That is fine as well, but I don't really like using 2.0 times 10 to the 9 because I really don't want to miss the 3, 6 or the 4. All right, so I would say use two decimal places when you write scientific notation. So that is the end of this part. If you think my instruction is helpful, like, subscribe, share. I appreciate your help really much, of course. I see you all in the next one.